All right, number 9 is a really important skill for calculus class. Calculus is the study of rates of change, and so you'll do a lot with testing to see if things are positive or negative, greater than, less than, that type of thing. So if you remember, in order to start solving a polynomial inequality, so again, polynomial being we have a, well, polynomial, inequality being that we have a less than sign. Sometimes we might have a greater than sign, sometimes we'll have a less than or equal to, or greater than or equal to. But what's important here is we don't just have an equation. But to start this process, you do pretend for a second, what if x squared minus 4x plus 8 were equal to 13? Well, to finish out solving that, I'm going to subtract the 13 over minus 5 equals 0. This is going to factor into x minus 5, x plus 1 equals 0, in which case I would have zeros at 5 and negative 1. All right, so that's my starting point for my number line. So negative 1 and 5 are something that make this function 0. Well, am I allowed to be equal to 13, or do I need to be less than? I need to be just less than. So thinking about less than, I can't touch negative 1. We'll put negative 1 right here. 0, 1, 2, 3, 4, 5. I also can't touch 5. Okay, so those are my zeros. They're open circles because this is strictly less than, not greater than. All right, so then I'm going to think about my different intervals. So I have this interval, I have this interval, and I have this interval. So I'm going to pick a test number from my purple interval. So my purple interval, I'm going to go ahead and plug in to my factored form. So x minus 5, x plus 1. And when I do that, if I plug in, let's say, a negative 3 was my test number. Notice I'm not plotting it on the number line. I'm just talking about the number negative 3. Negative 3 minus 5 is negative 8. Negative 3 plus 1 is negative 2. So a negative times a negative makes a positive. All right, well then this next one, I'm going to pick a number between negative 1 and 5. Let's say I picked 0. Again, notice I'm not plotting it. I'm just noting that I'm picking it. 0 minus 5 is a negative number. 0 plus 1 is a positive number. A negative times a positive will make a negative result. Picking a number greater than 5, I'm going to choose, let's say, 8. 8 minus 5 results in a positive number. 8 plus 1 is also a positive number. This whole interval is also positive. Well, I wanted numbers that were less than the 13 that I started with, which means I ultimately want to know where this thing is less than 0. Well, numbers by definition that are less than 0 are going to be this set of negative numbers. So my answer is going to be negative 1 to 5. It's an interval in which if I pick any number from that interval that's in green and I plug it back into the original, I should end up with a true mathematical statement. So let's try it. Let's say I pick 2. 2 squared is 4 minus 8 plus 8. Is that less than 13? Yeah. Pick any number, let's say 0. 0 minus 0 plus 8. Is 8 less than 13? Yeah. Pick another number, 4. 4 squared, 16, minus 16 plus 8. Is that less than 13? Yeah. Okay, so this whole green interval makes this original statement true because my polynomial, when pretended to be equal to 0, that negative interval is less than 0. All right, let's try it again. So again, I'm going to temporarily pretend that this thing is equal to 0. And I'm going to start by factoring. I'm going to take out a 4x squared. And so I'd be left with x squared minus x 288 divided by 4. Well, divided by 2 is 144. Divided by 2 again is 72. And I want to know where that's greater than or equal to. Oh, sorry, we are temporarily pretending it is equal to 0. So 4x squared, and then this is going to factor into x minus 9 and x plus 8. So my zeros, are x equals 0, x equals 9, and x equals -8. Again, these are things that are equal to 0. Was it okay to be equal to 0? Good. Hopefully you answered yes. In which case, when I plot these numbers, I can do filled in circles. So I'm going to pick 0 to be here, and I'm going to count by 2's. So here's 0. This would be 2, 4, 6, 8, 9. And -2, -4, -6, -8. Okay, so again, I've created 3 intervals that I need to test. Oh, sorry, I've created 4 intervals. Whew, counting, you know. All right, so I'm going to pick a number that is less than -8. I'm going to choose, let's say, -10. And I'm going to plug it into this 4x squared, x minus 9, x plus 8 polynomial that I've got. So if I plug in -10, this term is going to end up being positive. -10 minus 9 is a negative. -10 plus 8 is going to be a negative, so that overall result is positive. My green interval, a number between 0 and -8, I'm going to choose -4. So this term is again going to be positive because -4 squared will turn positive. This is going to be a negative. -4 plus 8 is a positive. Overall result is negative. Picking a number between 0 and 9, I'm going to choose 1. So 4 times 1 squared is positive. This will be negative. This will be positive. Overall negative. And then yellow, a number greater than 9, let's say 10. This will be positive. 10 minus 9 is now positive. Finally, that term changed. And 10 plus 8 is definitely positive. Positive times positive makes a positive. Now, my final answer needed to be all things that were greater than or equal to 0. So what I was testing when I got to this polynomial, greater than or equal to 0. Well, that means I want positive numbers. So this interval, -infinity until -10. And by -10, I definitely mean -8. -10 was my test number. I even said don't write it near the number line because you'll get confused, and here I am. Till -8, and then also this interval over here, which was from 9 until infinity. Now something to note also though, we had a 0 at 0. So x equals 0 you need to include in your set, because if you plug 0 into your original inequality, you do end up with a number that is greater than or equal to 0. But pick any one of these numbers. Let's say I picked 10 and I plugged it into this original function, okay? I'm going to end up with a number that is greater than or equal to 0. Next one, we have this polynomial that is a cubic, less than or equal to 0. So I'm first going to start by temporarily thinking about what if this were equal to 0? What would my zeros be? And I'm going to factor this one by grouping. Yeah, so I'm going to group these, I'm going to group these. So I'm going to take out an x squared, I'd be left with 2x plus 5. I'm going to take out a -4, and I'd be left with 2x plus 5. So this will become x squared minus 4, 2x plus 5 equals 0. So this will be x plus 2, x minus 2, and 2x plus 5 equal to 0, which means my zeros are x equals -2, x equals 2, and x equals -2.5 or -5/2. Just depends on if you want fractions or a decimal. Keep in mind, again, these are my zeros. These are things that actually make the polynomial equation equal to 0. Well, in this case, it was okay to be equal to 0. So I'm going to plot these on my number line. I'm going to go ahead and just call this one -2.5. And again, filled in circle because it's okay to be equal to 0. This then is going to be -2. This would have been 0, so 1, 2 for my number line. I don't really know if I have room, but we'll write it anyway. Okay, so next thing, I need to look at my intervals that I've created. I have this interval, I have this itty bitty little interval, I have this interval, and I have this interval. So time to start testing into my factored polynomial to see some results. Number less than negative 2.5. I'm going to go with negative 10. Negative 10 plus 2 is a negative number. Negative 10 minus 2 is a negative number. Negative 10 times 2 is negative 20 plus 5 is still a negative number. Overall, this thing is going to come back as a negative result. Picking a number between negative 2 and negative 2.5. Now this is tricky. I'm going to go with negative 2.25. Right, negative 2.25. So if I plug that in, negative 2.25 plus 2 is going to be a negative number. Negative 2 plus 2.25 minus 2 is still going to be a negative number. But this time, 2 times negative 2.25 is going to be negative 4.5 plus 5. That's going to get me a positive number. So overall, this result is positive. Thinking about this blue interval, I'm going to pick 0 because that's a nice easy test number. 0 plus 2 is a positive. 0 minus 2 is a negative. 2 times 0 plus 5 is a positive. Overall, a negative interval. A number greater than 2, let's go with 10. 10 plus 2 is positive. 10 minus 2 is positive. 2 times 10 plus 5 is positive. Overall, positive. Well, this started out as I wanted things less than or equal to 0. So that's going to be my negative intervals. That was confusing. That should be in blue. So my negative intervals, remember it can be equal to, so I'm going to use brackets, are going to be negative infinity until negative 2.5. And from negative 2 until 2. And you'll notice that my zeros, because I could be equal to it, those are all included with the brackets, as opposed to this last one where I had to include this one here, because it wasn't included as part of the solutions in these intervals. All right, last thing to talk about with these polynomial inequalities, I want you to think about the shape of your graph. So let's look at this one right here. When I have this thing equal to 0, this is a quadratic. This is a parabola that opens up. It's going to look like this. Well, these are all above the x-axis, and these numbers are all below the x-axis. So above 0 or below 0. This one is x to the 4th with a double root at 0. So x to the 4th, positive, opening up, and it's going to bounce at 0, which means I would have gone like this. And you'll notice above the x-axis, below the x-axis, below the x-axis. Positives and negatives. This one is x to the 3rd from the very start. Positive x to the 3rd, so I'm going to have down, up for end behavior. My zeros, nothing had a multiplicity of 2, so I'm just going to cross through these like a Disco Man graph. So this is below the x-axis, little bitty above, below, and then back above. So your graph is verifying what you found to be true for your polynomial values. All right, last one for this video, find a quadratic function in vertex form. That vertex form, it just keeps coming back. So f of x is going to be equal to a times x minus h squared plus k. Well, I know my vertex is negative 5, 2, so this is going to become plus 5, and this is going to become minus 2. I don't know what a is. I know that my x value is 4, and I know that my y value is 7. So a is the last thing I have to solve for. 7 equals a times 81 minus 2, which means that 9 is equal to 81a, which means that a is equal to 1/9. So in vertex form, it's going to be f of x is equal to 1/9 x plus 5 squared minus 2. This fits the criteria that you have a vertex at negative 5, negative 2. Plug in 4, you end up with 9 squared, which is 81, divided by 9 is 9, minus 2 is 7.